Hello there, and then welcome to a brand new lesson. This is Hub Beyond Numbers, where we learn maths the easy way. I do hope all is well with you. Now, in this lesson, we are looking at properties of real numbers, and specifically, we'll be looking at the closure, then the commutative property. When we even talk of property, they are just the rules that define how the numbers behave and then interact. We will mainly focus on addition and then multiplication operation. So without much I say or do, let's quickly look at the closure property. So talking of closure property, we say a set is closed under an operation if performing that operation on any two elements of the set always produces a result that is also in the set. What does this definition here mean? Let's look at this over here. Just to explain, I'll use, let's say, even numbers here. I'm going to write even numbers in my first circle, and then odd over here, right? So the odd being D. So this is a room that contains even numbers, and this is also a room that contains what? Odd numbers. Now, if I take two even numbers, let's say 2 plus 2, if I add it, do I get an even number? Yes, I get an even number. Any even number at all. So you realize that for any even number I take, if I add another even number to it, I'm going to get an even number. I'm taking two numbers from the set, and it will give me another result that is also in the set. On the other hand, if I take two odd numbers, for instance, I'll take 3 plus 3. 3 is an odd number, and this 3 is also an odd number. If I add it, what do I get? I get a 6, which is an even number. Do you see that? What if I add 3 to 5? These are two different odd numbers. What does that give me? It gives me an 8, which is also an even number. You would realize that if I take the operation addition and I work it on any or some numbers in the set of odd numbers, I am not going to get what? Odd numbers as my answer, but rather I'm getting from another set. So what we say is, for the even numbers, the operation addition is closed. Closed meaning that anytime I work addition on a set of even number, it will give me another even number. It will not go to another group of numbers to give me the answer, but it will give me the answers right in its set. But for odd, you see, it doesn't give me an answer that is also odd, but then it goes somewhere else to go and pick the answer. That is what the definition is saying. So a set is closed under an operation if performing that operation on any two elements of the set always produces a result that is also in the set. Now we want to look at this case for real numbers. Now for real numbers, let's generalize it. You realize that if you take A, right, which is an element of a real number, and then let's take B as well, which is an element of a real number, right? You would realize if you take A plus B, that is, if you add A to B, the answer you get is also a real number. You see? And obviously, if you multiply as well, the answers we get are always real numbers. You see, example, if you have to take 2 plus 4, the answer we get is 6. Is 6 not a real number? They are all real numbers. And if you have to take multiplication as well, so let's say 8 times 3, we get a 24. And these are all real numbers. So we say that the set of real numbers is closed. It is what? Closed under addition and multiplication. The set of real numbers is what? Closed under addition and multiplication. This is just the case for all real numbers. Okay, for all real numbers. Now let's consider just natural numbers. Just the natural numbers. So for our natural numbers, and we want to determine if it is also closed. Now, if we take 3 minus 5, we know the natural numbers start from what? 1, 2, 3, and then it goes on and on. So 3 minus 5 gives us a negative 2. This here is a natural number. 5 is also a natural number. What of negative 2? Is it a natural number? No. It is an integer. You see? So since the answer we are getting when we are subtracting is not a natural number, then we'll say that the natural number is not closed under what operation are we using? Under subtraction. You see, natural numbers n is not closed under what? Subtraction. You might ask, what of addition? Are natural numbers closed under the operation addition? Yes, of course. And you can prove that based on the understanding you have now. So basically, this is what we call the closure property. Let's look at the commutative property. So talking of the commutative property, mainly on addition and then subtraction, addition and multiplication, we say the commutative property states that the order in which you perform addition or multiplication does not change the final results. The order. What do we mean by the order? So mathematically, I'm just going to write the rule being A plus B is equal to B plus A. You see, so all I have done is I have changed the order. Instead of writing A first, I want to write B first. And the commutative property is telling us that the order doesn't change your final result. See, so for instance, if you have to take a number such as 2 plus 5, we get a 7. And it's the same answer we get if we choose to write 5 plus 2. So as you can see, the order has not changed the result. What of multiplication? So we have A times B being equal to B times A. Is that true? So we have 4 times 3. The answer it gives us is what? 12. And it's the same answer we would get if we were to evaluate 3 times 4. You see? So the commutative property generally is actually A operation B equals B operation A. That is for a general word operation. But since in this case we are talking about addition and multiplication, that is why we limit ourselves to them. All right. So what of subtraction and division? Taking these examples, you realize that they are not commutative. So for instance, if I take 2 minus 5 and I'm to work 5 minus 2, do I get the same answer? 2 minus 5 gives me a negative 3, but 5 minus 2 on the other hand gives me a 3. Hence, they are not the same. And we say it is not commutative. The same applies for division. If you have 10 and you divide it by 2, it is also not the same answer you get if you have to divide 2 by 10. One gives you 5 and the other gives you a 0.2. Right? So basically, these are the commutative and the closure property. Let's solve some questions to test our understanding. Okay, so we are taking our first question here, which says, is the set of irrational numbers closed under multiplication? the set of irrational numbers, is it closed under multiplication? So what do we actually want to prove over here? You want to prove whether or not, if you take an irrational number and you multiply it by another irrational number, are you always going to get an irrational number? If you are able to prove that this is not always the case, then it simply means it is not closed. So all you need is a counter example. You see? Now, if you have a basic knowledge on sets, then for A, which we would call, let's say, root 2, if you multiply root 2 by root 8, our basic knowledge in set would tell us that we have to evaluate 2 times 8. You see? And 2 times 8 then gives us what? A root of 16. Root of 16, on the other hand, is a 4. And look at what has happened. We have multiplied an irrational number by another irrational number. And the answer is given us is a rational number. So this alone is a proof that the set of irrational numbers is not closed under multiplication, because they multiply themselves and then they give you an answer in another set. They are not closed. You see? So our answer is, since 4 is since 4 is a rational number, then it simply means the set of irrational numbers is not closed under multiplication. And that is all. Very simple and direct. Okay, so this question says, state the property illustrated by this equation over here. Even though we've not done associative property, if you have a pre-knowledge of it, you might think that is what you see. But anytime you have these questions, you have to pay attention to what it is. We have 1 over 2 here and a bracket. Now look at the content of the bracket. It is the same thing we have over here, then plus the 1 over 2. You see, the brackets have not changed. The same content are what we have in the bracket. All that has been done is there has been a reordering. The first, which is the half, has become the last. You see, so from here it has moved towards the last one here. And then this, which was the second, is now the first over here. So we have just reordered. And reordering, does it ring a bell in our ears? That is commutative property. You see, because it's just the positions that have been changed. So we would then say this is the commutative property of addition. And that is all. You see? Yes. So I think it's enough. I would give some exercises for you to try on your own, just to test your understanding. So these are the questions, and the first one says, which property allows us to write 11 times x as x times 11? Then the second one is just a true or false. The third one, it says, is it true? If not, state why this property doesn't apply. And then the last one also says, does the set of whole numbers satisfy the closure property under multiplication? This is the end of this lesson, and this is How Beyond Numbers, where we learn maths the easy way. If this lesson was helpful, you can always choose to subscribe if you so do wish, so that anytime I release a video, you'll be notified as well. See you in our next lesson, and bye for now. Take care.